Sure. First thing first, let us get some data. But even before get some data, in many cases, I think it would be a good idea to have some idea about the data. So let's have a look what kind of object we are dealing with, which is data. So we get some data manipulation tools, which I will use Torch in this example. Check. Torch is a very useful tool that helps you to organize the collection of numbers into some regular form as tensor. And the tensor is an extension of the concept of a matrix. A matrix is a two-dimensional array. You have the numbers organized in rows and columns. I will show you a matrix right now. Torch random dot look, this is an array. You have 3 rows, and in each row you have 4 columns. That is 4 elements of numbers. Of course, those are just the random numbers without much meaning. And Torch allows us not only deal with matrices, which is very common, useful in mathematical computations, operations, but also it allows you to have a multidimensional arrays. For example, in this case, it has 3 layers of matrices, and in each of the layer, the matrix has 4 rows. This is 1 layer, and in each of the row it has 2 elements here. Now you have 3 layers, and in each of the layer you have the 4 by 3 matrix, and that is the 3-dimensional tensor. And also, it can be as simple as just the 3 numbers, and the 3 numbers organized together would make you an ordered sequence. Of course, a vector. Okay. Torch also provides us a set of tools to do computations between tensors. That includes matrices and vectors. For example, if we let this to be in a variable, call it a. Run this, and we got a. So to verify, let us print a. And oh well, look in the notebook, and each piece of code can be organized into such a box. It's called a cell, and each of the cell can include multiple statements of codes. When you click run, it will execute the code in each of the cell in the cell, and gives us the result in the output box. And the code can be organized or experimented non-linearly. That means you can experiment with some boxes and then go back, do some adjustment, and reiterate some of the code, which is very common too, to experiment with ideas. In this case, let's click run here, and if you are using Windows or Mac computer or Linux, maybe all the same, you can click Ctrl+Enter to run a cell. Let's run it here. Oh yes, look, the shape of A, that means it's well, shape is a vector, has only 1 dimension, and in this dimension has 3 elements, and the value of this A is such numbers. Notice that these 3 numbers are different from the ones we have just seen. That is because by executing this cell, we regenerate 3 different random numbers here. Okay, let's call A3 is A multiplied by 3.0. What will happen? Check. You can click those white spaces to create new cells. This experiment. If, for example, we have yes, print A3, and we can verify the calculation. Okay. Can write a for loop in a range. The range is 3. That means I can be 0, 1, and 2. Let us print I and the ith element in A. Notice that in Python, the convention in Python for any indexable object, the index begins from 0. That is the same as in C, C++, Java, etc. But it's different from MATLAB if you use that before. And AI times 3.0 and a 3i. This is to verify that Torch actually perform the vector and scalar multiplication as expected. Okay, let's execute this cell. Have a look. The zeros element AI is this number, and AI multiplied by 3 is this number, which is exactly the same as the computation result of Torch. And you can verify, although this is a little bit complicated form because the value may be a little bit small, but yeah, we verified that. Torch performed the computation successfully. Other computation includes, for example, matrix and vector multiplication, such as let M to be vector matrix such as torch dot random and let it to be maybe 2 by 3. So M could be multiplied on the left side of A. Okay, so print M. I believe the right function to call to compute the multiplication between M and A should be dot. It turns out I mistook the function in NumPy with that in Torch. In case you would wonder why sometimes we use one computational framework and in other cases we use another one, I provide some references to explain the relationships between those computational frameworks. But for now, I found that the correct function to use in Torch for the multiplication is this one called matrix multiplication. Let's try. Okay, there is another issue. If you are experienced, you may find that is because of the shape. If you are not, remember the trick we talked to search the error message. That would bring you some hint on the solution. A bit more specifically, which we will see later in this video, is that the matrix is on the left hand side and the vector is on the right hand side. So in this case, the number of rows in that vector should be corresponding to the number of columns in the matrix to complete the multiplication. However, the vector in the variable a is only organized as a one-dimensional object. There is no rows or columns, just the number of elements in that object. So the reshape forces the library to view these three numbers as column vectors with 3 rows and 1 column. At this stage, you may want to take some notes about the stuff we have learned. A very convenient way of using the notebook is let us create a new cell, and if you hit escape key, the very left top key on your keyboard, you will find the box becomes from green to blue, and in this mode, if you hit M, you will convert a cell from the code cell into a mark cell, which is useful to do the do nodes. Let's just write OK in torch. The matrix multiplication is the OMM function. See, you can add hyperlinks here, and I copy the URL here. Look, our good old friend Stack Overflow appears. So, and I do some explanation to compute. It supports LaTeX. Some of you may have written academic papers, may be familiar with matrix or LaTeX times B, where A and in a pair of dollar symbol, those symbols would be treated as matrix symbol, math symbols, where NB are matrices. You should use. We can use this joke symbol to mark the beginning of a piece of code. Note this is different from the single quote symbol, and that is the key that is on the left of the number 1 key on the keyboard. And you can also specify the language of your code to automatically have some syntax highlights. On to Google Markdown document for more details about how to write notes in this way. If you execute Markdown cell, that is a note cell, let's see the effect, which is pretty pretty. And okay. You may also want to verify the result of the multiplication. Notice there is a reshape here because A has 3 numbers, but these 3 numbers are treated as a one-dimensional stuff, which means there is no column or row vector distinction in the internal representation of torch. So to make it multiplicable with matrices that has 2 rows and 3 columns, we need to formulate A as a column vector, which we reshaped it into a 3x1 singular matrix or a vector. So to verify, let us say let S to be 0, and for I in range 3, S is cumulated by M 0, and I, the first row of M and the ith element multiplied by the ith element in A. So the result of S should be the same as this number, the first row of the result of multiplication between M and A. S. Check. Look, that is 3.84 something, which then you move the period to the left by 2 digits. Exactly same. It's good.